All right. Back at it. Okay. Number 2. If we know that u substitution helps us rewrite an integral into an easy to find form, what is the clear inner function in this guy?
Actually, there's one.
Yeah, right? Okay. Yeah. So then check and see, is x squared plus 1's derivative also present? Yeah, 2x, right? So let's check it out. We are going to let u equal x squared plus 1. du is 2x dx. All right, I see my 2x dx. He is right here. I see what should be u. He is right here. How should I rewrite this integral with u's? Good job. U squared du. Don't forget your du's. Don't forget your dx's. Let's integrate. Okay. And then now we need our answer in terms of x's. So we're going to go ahead and substitute back in. X squared plus 1 to the third over 3 plus c. Yeah.
Unlike the IB and stuff, do we have to use U and V where like for like product rule and stuff? Or can we just define any letter as a certain thing?
What letters are you going to use?
I use it like I go in alphabetical order.
All right.
I just hate using U and V.
Did you get the answer right?
Yeah.
All right. The only reason I choose U and V is because when you do integration by parts next year, that's what you use. So I don't know. It's just like a nice skill to like, oh, I'm already comfortable using U's and V's, and you know what I mean. So whatever. If you get it right, cool. All right. What started out as a nightmare is now becoming manageable. Cool. All right, try. Ooh, 3 is a little tricky. Okay. What is the clear inner function on 3? Wait, actually, this is not the one I was thinking of. This one is not tricky at all. It's my x plus 1. du is 5 dx. Here's our 5. Here's our dx. Here is our u. Integrate. Were you guys abducted by aliens? Are you okay? That makes sense because they do have an upcoming exam on May 1st. I get it. Oh my god, I'm kidding. I'm just trolling you. It's fine. All right.
Excuse you.
You ready? Number 4. Yay. Okay. Number 4, clear inner function. All right, for the purposes of time, I'm not going to keep highlighting du and u. Are we good? Are we starting to see where they go? Okay. Okay. So the next page is what?
Why is it over 5?
I had to integrate. It was u to the 4th,
Never
so
mind. I have 1/5 saying I'm being stupid.
You're not stupid. Don't say that. Okay. So on the next page, I wanted to introduce this to you first so you can see how we can manipulate the du in order to pull constants out. The next page is a continuation of that. So let's go ahead and look at the next page, okay? So tool number 2 is called multiplying and dividing by a constant. If you can divide both sides by a constant to get du in a form that's present in the original integral, you can also multiply by a constant to get a constant that is present in the integral. All right, so like take a look. 5 you've already done. See if you understand 5 and if you can do it. We'll just do it together. I mean, like, what am I going to do? Just stand here? Okay, let's just do it together. Okay. Yeah, we'll just do 5 together. Okay, so who is our clear inner function here?
Oh, this is still a du.
Yeah. And then du is going to be 6 dx. Is there a 6 in the integral that you see right there? Square root of 6x minus 5.
Or like,
Yeah, I'm asking, like, is there like this?
oh no.
No, right? So,
Oh, can you multiply by 6?
well, I'm going to divide both sides by 6 because I want to get that 6 out of there. Now I have 1/6 du is equal to dx. I have a dx in here, so I'm good. I'm just going to put that 1/6 out in front of the integral, okay?
I have a question.
Yeah.
Since there's no like 6 out front, and like we did it the other way yesterday, why would we how do we know when to use it? Where can we use just both?
Since there's no. Oh, so you're like, how is this clearly like a
Yeah.
u substitution? How do I know? Because inside, like yesterday, right? The ones that we had yesterday were kind of just like the square root of x. In here, there's a 6x minus 5 inside of the square root. So there's like, just visually looking at it, and I was like, hey, but what's the inner function? This guy has one. Because you're like, okay, there's
So
like
there's an
multiple
inner
things
function.
inside of it. And if you have something that looks like this, right? So it's like, I mean, like technically there's an inner function, it's just a plain old x, but you can just rewrite this as a singular power and then integrate.
But you
So-
can't do that. You couldn't do that first and just keep the 6x minus 5 at 6.
You could, because you know that the 5 would drop out, but I feel like
I
this
feel
is
like it
just
would
a really
complicate it.
clear way to be like, I'm never going to mess up the constant. Because then you're going to have to manually in your head know that there's a 1/6 out front. Which you kind of do when you start getting with just plain old e's, which you'll see. But, okay. Good questions. All right. You guys ready to go on to 6? All right. Clear inner function on 6. What is it? Yeah.
This is how you showed us before. Can you show us this?
Did I? Did we already do this one? Is this the example? It looks like the example, doesn't it?
It's not the example, but it's similar. It's like the same concept.
Oh, it's so close. There's just a different constant. Sorry. Well, then you should definitely be able to do this one. So,
Well, so you did show us the 20 constant.
yeah, no, I definitely showed you guys this before. This is kind of just a continuation. Tool number 2 is like often not a separate skill. Ooh, actually, this is good now that you guys are getting good. I'm going to forget something on purpose.
Ew.
Tell me what I forgot. Oh, wait.
You forgot the thing out front.
What did I forget out front?
1/4.
Good job. You guys are getting it, man. Oh, wait, I want to sub in. Ah. I'm sorry. What was that?
Jason's speaking.
All right, what do you think about 7? Are we going too fast? Are you guys okay?
Oh, we got it.
What about 7? Inner function? du. Ooh, there's no 2 in there. It doesn't look like a 2 at all. That looks like one of Jason's 9s.
Hey.
All right, why is 8 a little tricky? What do you guys think? Have you guys done anything with fractions just yet? All right, don't free. Two have gently passed. They've left us. Oh, they're back. One's back.
You passed?
He's gone again. He was only here for a brief time, but he did light up our lives while he was here. Okay, so now let's look and see what is the clear inner function here. Du is, ooh, careful, negative 2x. Whenever there's the constant out front and the x is negative, I feel like kids always mess that up. But you didn't get messed up, did you? Nah. All right, so what am I going to divide both sides by?
-2.
All right, now think, right? Hold on, let me split this up for you so you can really see what's going on, okay? So if I have something that looks like this, right? I've got 1 over 1 minus x squared to the third times x dx. Is it a little more clear now what our substitution would be? Like, what would u be? U would be to the power of what? What kind of 3, though? Yeah, because he's in the denominator, okay? So now you would have a negative 1/2 out front, and it would be u to the negative third du. Yeah? Yeah. Oh, wait, what am I doing? I didn't add the power yet. Hello? I'm running out of space. Ooh, Joanna's working ahead. Joanna, what's my U for the next one? Number 9. Same idea, right? Let's split it up. Hold on. Actually, sorry, I asked you a question and then started immediately talking. That's cool. Let's split it up first in case it's not clear to anyone. Okay. What's our U? Good job. So du is going to be negative 2x dx. Is this the same as the one above? No, they're different. Okay. All right, so now if I integrate this guy, I'm going to add 2 over 2 and get 1/2 times 2 times negative 1 over 2. So I now get negative u to the 1/2 plus c. That's a bit weird equal sign.
Oh, never mind.
Oh, 10. Are you ready for 10? What do you think we should do first?
U equals ln x.
I like that idea. When I let u equal the ln of x, what's du going to be? Oh, okay. So if I rewrote this guy, right, for anyone who's not seeing it,
So it does match.
do you see now, like, where Jason's going with this?
So I just read.
U to the 10th du. Yep. Yep, good job. All right, so now let's try like one of the harder word problems from the beginning. Let's warm up with 4, and then we'll try 3. So go back to page 10, and we're going to do number 4. Okay. So it says a gradient function is given by dy dx equals 10e to the 2x minus 5. When x equals 0, y equals 8, find the value of y when x equals 1. So what you're going to want to do is you're given the derivative, so you're going to want to integrate him, right? Once you integrate him, you're going to get a plus c. You're going to plug in the initial conditions, and you're going to end up with that c, right? Then you're going to sub in 1 for x and see if you can return a y value, okay? So you can do this one of 2 ways, but I feel like this is the first one we've done with an e. Once you start doing a bunch of these, you'll start to not have to use u substitution with this. But in the beginning, I do want to show you how to start, okay? So are you sleeping but you're sitting up?
He's actually dead.
One time in church, I fell asleep standing up when I was like 12. And I fell over and like knocked over an elderly person. It was very embarrassing.
Was the priest?
What?
Was the priest?
No, I was like standing there and I like fell asleep and like the person who was
You
like
landed
standing
on the
next to
priest?
us. No, like a person who was like a person I didn't know.
Wait,
Who was
you
like
know
standing
the person
near
when you
us.
were younger? Wait,
Yeah, no, I
you
didn't
not
know
come
them.
over while you were sleeping.
I like fell asleep and then I fell over and I knocked into them and I felt so bad. But anyway, here's what we can do.
They're both standing there.
No. If we break this up, is it kind of easier to see how we would use u substitution to find the constant for the first part? Are you finding a constant for the second one? No, you're just going to integrate it and it's going to be really easy. But this is when it becomes useful for you to break stuff up using your integral rules, because like I'm going to do a u substitution on one part. I don't want to have to do u substitution on 2 parts if I don't have to, right? So I'm going to kind of like take this piece and like isolate it, right? I'm going to do a u substitution on that, and then I just don't want to forget that the other piece is there, so don't let me forget. Okay. I want to use a different color. Let's use rainbow. That's fine. Yep. So here we
How
go.
do you take a 10 out? Not out of the 5.
Because I split up the integral first, and then I took the 10 out of the first integral. And I took the 5 out of the other one just because. I don't know. I didn't have to. But okay. So now I'm going to let u equal, what's the inner function with the e guy? 2x. So du is going to be what? Dx, right? So you divide both sides by 2, divide both sides by 2. Do you see how like after doing a few of these, you'll start to see like you just have an e, you'll get an idea of what the constant out front would be. Maybe. Can you still do it the long way? Sure, of course. So now you'd have 10 e to the u du. What's the integral of e to the u? E to the u, right? There's a 1/2 out front. So now I would get 5 e to the u. And then we're going to use that little piece to rewrite in terms of x. So now I have 5e to the 2x minus, and then do the integral of 5 dx. What would the integral of 5 dx be? 5x. Yep. So do you see how it's not hard? You just have to like keep track of stuff. You just used the u substitution to find the constant that you would multiply by. Can anyone think of like an easier way to remember? If you have e to the 5x, what's the constant up front going to be? Well, yeah.
And you can put a 5 there beforehand and then it equals out.
Yeah, if there was a 5 there already, you're 100% right. Yep.
Instead of taking out 10, I just took out 5.
Oh, if you're considering the 10, yep. Yep, cool. All right, so now we've got this guy, and he is our original, right? So it's kind of like y equals 5e to the 2x minus 5x plus c. So when x equals 0, y equals 8. So let's put the 8 here. 5e to the 2 times 0 minus 5 times 0 plus c. E to the 0 is 1, so we have 8 equals 5 minus 0 plus c. So we have our c. So now let's write the whole equation, right? So we got y equals 5e to the 2x minus 5x plus 3. And what are we ultimately trying to find? Find the value of y when x is 1. So I'm going to sub in a 1 for x. That's it. Okay. I want you guys to try 3 on your own. You're going to use the same idea that I used right here, where I split up the integral along the pluses and minuses. Where do you think you're going to split up the integral for 3? Look at it. Yup, the plus sign. Good job. Okay. Let that get you started. Go ahead. And then just keep in mind that x is less than 1. So
Is supposed to start us for the day.
what?
Why were we supposed to? Why was this on the beginning of the day?
I don't know. That's why I was like, skip these two. But keep in mind that x is less than 1. So when you take the ln, I just kind of gave you the answer. That's okay. Just work through it. See if you can figure it out. I'll be around. I will put the solution on the board.
This fall, did you eat your lunch today or no?
I put a dent in it for sure.
More than usual.
More than usual.
Let's examine.
Pretty good, right? Pretty good.
3 bites today.
I have a lot to do. All right, let's see. How did you guys do? All right, so your DU shouldn't have U's in it, right? So check it out. If you've got, you would let U equal -2x, right? So DU is the derivative of U. It's the derivative of U with respect to x, and then we move the dx over to the other side after we take the derivative. So it'd be -2x, right? Divide both sides by the -2.
I think he is worse than that.
All right, here, you guys can check your answers.
He can't. He is.
No, I haven't seen that.
It's not working. If it was working, he would be like.
Okay. Looks good. So then now you have -1/2, right? E to the U. If you took the integral of this, that would it's the opposite of or what's the standard?
I mean,
He's not.
No, it wasn't.
Which is easy. What's the derivative of U?
Oh,
So
yeah.
what if you work backwards? It's the answer.
No.
Yeah. So you would get
Her shape her face.
right? 2x. Now we have -1/2.
You just started yapping.
It's not
possible. Making it worse.
Did anybody get it right? Or you guys didn't?
I did.
I did the first time.
I
could-
like plug and blind. I got the
Concept.
yeah.
All right, so then here you would let U
Bro, the RNG.
equal 1 minus x, right? So then when you take the derivative of that, you would have negative
That was actually crazy though.
that. So you need to divide both sides by -1, so you have negative du equals dx. So now you have this guy minus 1 du and of u plus c. Negative ln of argument back in 1 minus x. It's hard to do ready work around it. I'm like working around, but it's like kind of all over the place. No, it's good.
I
And
know
then-
it's like the starting point.
Yeah, so then these are the two pieces, right? So now you have -1/2 e to the -2x minus the ln of 1 minus x. That guy got me too in the beginning. I said plus ln of 1 minus, and then it was like, oh, it's negative. Plus c. And then now that's your function, and then now you plug in your initial conditions. Okay?
Thank you so much.
Yep.
I'm so sorry for being late, by the way. We were just
Well,
bring that-
it's just giving you guys garbage.